one of the things I picked up was understanding dyslexia through neurosciences. And neuroscience, it has proven something powerful. It has moved us from stigma and guesswork. And if you look at the dyslexic brain, it's not less, but it's just wired differently. It's not wired less, it's wired differently. And from my research, I believe it processes information like a 3D engine. Okay, and which is basically, and if you think about a 3D engine that harmonizes with spatial intelligence, you look at big picture thinking, it understands diverse patterns, it has spatial awareness, but sometimes it is hard for it to combine all that into what we consider instant information recognition. So, and if you look at MRI studies and a lot of ECG mappings that have been done lately, as well as computational neuroscience, it reveals that dyslexic brains use alternative neural pathways. And they basically exhibit strong, what I would call right hemisphere activations within the brain. And they also excel in big picture thinking, reasoning. And if you look at, a number of research that has been done with artificial modeling, you see 3D recognition of how people with dyslexia actually recognize imaging. And they access creativity and associate memory with systems. And one of the most important things I learned from my research was the superior context and relational thinking that is combined inside the rewired mind. So if you think about it from that perspective, this brain wiring is not a deficit. It is not a deficit. It's an evolutionary cognitive diversity. And these are the minds that imagine, invent, and build and transform things like over years and decades. Quite a lot of scientists will actually come into this space. And in the age of AI, we can actually use this to harness the creative intelligence, the innovative intelligence, and the problem-solving skills that we could also use in our societies today.